Hello. In this video, I want to go ahead and look at L on question 1 for the review for exam 4. So we have the integral of 9e to the 18 square root of x divided by the square root of x dx. Now, just like last time, because we have an exponential, we want the exponent to be the u value. So let u equal 18 square root of x, but that just means 18x to the 1/2 power. So what that's telling me is that du here is equal to, well, 18 times a half is 9, and then x to the negative 1/2 power dx. Oops, I don't know why I switched to green there. Oops. So 9x to the negative 1/2 dx. Good. Now notice that I can actually rewrite this as 9 over, technically the square root of x if you want, but I'm going to leave it as x to the positive 1/2 dx. So notice that the 9 and the square root of x there is this 9 and this x to the 1/2 power here, and the dx is dx. Also notice that the 18 square root of x is 18x to the 1/2 power, and that's just u. And I've actually accounted for everything over here. So now this is going to become the integral of just e to the u power, and instead of 9 over the square root of x dx, that is just du. So while it looks really difficult here, it actually simplifies to a very simple antiderivative. And again, it is its own antiderivative, so it will become e to the u power plus c. Remember, u here is 18x to the 1/2 power, or 18 square root of x. I'm okay with it, whichever one you want to use. And there you go. That is L. Now let's look at M. The integral of x to the 5th divided by 4x to the 6th plus 2 dx. Now notice that there isn't any parentheses really around anything, but notice that in the denominator here, its derivative x to the 6th becomes an x to the 5th of some sort. It's off by a coefficient, but that's okay. So what that's telling me is I want to go ahead and let u equal the denominator of 4x to the 6th plus 2. And notice I didn't divide by this here, each of these terms, because there's more than one term down here. And so I can't break it up into separate fractions. So now we want du to become the derivative of 4x to the 6th is 24x to the 5th. And then, of course, throw on a dx because the 2 becomes a 0. Notice that we have an x to the 5th, but not a 24x to the 5th. So I need to get rid of the 24 by multiplying by both sides by 1 over 24. Good. So the x to the 5th dx is 1 over 24 du. And the 4x to the 6th plus 2 is u. So this will become the integral of x to the 5th dx is 1 over 24 with a du out here. And 1 over 4x to the 6th plus 2 becomes 1 over u. So here's what we have. 1 over 24 times 1 over u du, the integral of that. And notice that, again, 1 over u, its integral, or its antiderivative, is the natural log. So this is going to become 1 over 24 times the natural log of the absolute value of u plus c. So this is actually 1 over 24 times the natural log of the absolute value of 4x to the 6th plus 2, plus a constant. And there you go. That is M. For N here, the integral of 3x plus e to the 2x dx. Now, after having done a bunch of u substitutions, we throw a curveball in here, and this, you just find its antiderivative as is. Now, the antiderivative of 3x here. Well, first of all, add 1 to the exponent, makes that x squared. Divide 3 by 2, that gives you 3 halves. And then plus the antiderivative of e to the 2x, well, just rewrite it and divide by the derivative of the exponent, which is 2. I'm just going to say go ahead and put 1/2 instead of divide by 2. And then plus c. Now, if you notice, that's it. That's all I have to do. Alrighty. Well, there you go. There is L, M, and N. And this concludes question 1 for the review for exam 4. All right, I'm going to go ahead and end the video here, and we will continue with question 2 in the next video. Have fun.